There's various different networks that Danfoss supports. In UK, it's really common to use the Ethernet connection. Most other places, they like to use the RS485 with the Danfoss front ends. So you should have around about 2 volts difference between your A and your B line. The 485 standard is anything above 1.5 volt difference so that it can see what's going on. It's worth checking. I would say with network fault finding, and we could do hours and bore people to death probably on network fault finding.
Yeah.
Network fault finding is all about using logic. If you've got a whole island off and the island next to it's on, the chances are your fault's on the cable between. If you've got one case on an island off, you can sort of break down where that fault is going to be. It's worth having a look, see if you've got a voltage difference there as a little indicator. But network fault finding, and I've done a lot of network fault finding over the years, is very much an exercise in organization and logic. Look where you've got things that are talking, look where you haven't got things that are talking, and then upset the store manager by telling them you need to get in the ceiling in between them, usually.
Yeah.
But it is worth checking.
Okay, welcome to another CO2 expert. Super pumped up for today. We're going to be diving in to MXPro and AK550. My good friend Kevin, we've done a couple of podcasts together already. This guy is an expert. He has helped hundreds of technicians. He's solved thousands of problems on CO2 systems over the years. And we wanted to talk about case controllers because we know this here is not new to the industry, but it's still new. And the way we troubleshoot and walk through things is very, very important to your success when you're out in the field servicing CO2 systems. Kevin, how you doing, brother?
I'm good. It's good to see you again, Trevor. Thanks for having me back.
Oh, love
sorry for talking rubbish to you and making the meeting late starting.
No, that was all me. That's all me. Okay, let's just dive right into it. How long have you been working with the Danfoss AK550 and the Carel MPX?
Wow, the 550 probably early 2010s, I would say. So a good few years. The MXPro we came to a little bit later, sort of 2015 probably, 2016, something like that. They're both really good pieces of kit. It's a good one to talk about because neither of them are super friendly if you're coming up to them for the first time, because it's buttons and item codes and all of that. So they're good ones to talk about. They've got a lot of features that don't necessarily spring to light easily. So we need to sort of point out the key ones. As we were saying yesterday, there is no way we will be able to cover everything on these controllers in this, but hopefully we can give some pointers as to common things that people are going to see, common things they should be looking for and checking when they're on site.
Yeah. One of the biggest things is that you need to get the manual. You need to get the wiring diagram from that manufacturer because they have wiring diagram, and the manual of the controller as well. And it's not always easy to go through it. Me and Kevin were looking for some parameters on their newer controllers yesterday, and the parameters aren't there, but they're in the controller. So this is some of the things that it happens with all manufacturers. So and they're all good ones. All of them out there, they all do work really hard to make good controllers. We just really need to understand them more. And when you understand the controller more, you can troubleshoot it quicker and easier. Okay.
Absolutely.
Awesome. Let's start with here. This is out of one of the sites that you used to work on. This is electrical wiring diagram. They can look different. Let's talk about what's the important things to look at for this controller here, the Danfoss one.
Yeah. So important things to consider. This is the 550A version of the controller, which was the adapted for CO2 version of it. The main difference between the 550 and the 550A that we'll be concerned about is with the original 550 that worked on, they had designed for Freons. You could use a coil-in probe for your evaporating temperature or a transducer. With the 550A, they want you to use a transducer for your superheat calculation. You can't use the coil-in probe. So we have got a transducer on there, all your probe assignments at the top. Obviously, if anyone worked on the old precursors to this controller, you'll know that had a DC expansion valve on it. This has got an AC expansion valve. Key when you're changing the coil on site, you know, if you've got one on the van that you've had for 10 years and it's a DC one, it ain't going to work with this. So be aware of the differences on that. I think, yeah, the first, if you'd say looking at the top there where your probes and your transducer is, just as most people will know, every controller manufacturer likes a different order to their probes. So just make sure you know what probe goes in where, because what worked on, let's say, a Carel for your order of your probes won't be the same on this. So this likes to do your superheating probes first. So you've got the transducer, which is sensor 1, your coil outlet probe, sensor 2. So that's how your superheat's been calculated. That is the key thing. Then you've got your air on, then your air off, then your defrost. When we look at the MXPro in a bit, the order is completely different. So just make sure you know where everything is. As I say, AKV, which is your pulse valve, your expansion valve on these controllers. On this controller, that is tied straight into the line, and all you're doing is switching the line voltage on and off. So if you're in the UK and Europe, that's probably 230 volts, single phase. If you're in the States, that's probably the 110, 115 volt version. But you're switching the line voltage to it. So when it's dunked in water in the bottom of the cabinet, as you'll frequently find them, just be aware there's line voltage on the plug.
Yeah. So the first step, let's go through the process of when you're going up to a controller and you're going to go to do a maintenance. Okay. Just say the system has been running fine. What are the starting point? I know we talked about yesterday. The first thing we need to see is what's that supply voltage coming in. Do you want to walk through some other steps? Yeah,
sure. So as you've got marked there, supply voltage is going to be key to anything working on this controller. The chances are, if you've got a problem on that, that screen is going to be blank when you walk up to it. So let's say, if this is, let's say, a cold store with 6 evaporators in it, they might not notice if one of them's gone off. So that's going to be your start point. Nothing is going to work unless you've got the 230 there. Yep. If you've got the 230 there and the display's on, what you'll see on the 550 and the 550A, what you see on this controller, you can see the cooling and the fan lights are on to the left of the numbers. If it's in alarm, all 4 indicators, because there's the valve indicator and the defrost indicator on the side there, they'll all be flashing. And we actually talked about this last night, didn't we, Trevor? If you just touch the top button on the controller, it'll give you status code for what the controller's doing. And you want that to be telling you that it's in regulation or startup. If that's giving you an alarm code straight off, or it's giving you a status code saying it's stopped, then you know where to look around the rest of that controller. Assuming it's running, but let's say for some reason it's not cooling, hidden underneath those probe wires there is the plug for the AKV, which is obviously Danfoss's expansion valve. There we go. So as I said, difference to the old Danfoss controllers, all this is doing is taking the line voltage and switching it on and off through a big transistor. So you're going to want to check that you've got a voltage going into that and that you've got a pulse coming out of it. It's not going to be on, see, 5 and 6 there. So that's going to be your supply in and then your feed out to your valve. So you're not going to see on the output of that permanent voltage. What you're going to see is probably 3-4 seconds at the most on and then off and on and then off. The standard timescale that Danfoss works on is 6 seconds. So you will get a percentage of 6 seconds on depending on how much valve drive it's asking for. So yeah, just check you've got a voltage out to your coil. If you've got a voltage out to the coil and you're still not doing any cooling, then you're going to be at the coil end going, has my coil burnt out? You can take the coil off, do a continuity test on the coil. The exact value isn't really important. It's going to depend on what voltage your coil is, but you are going to want to see some resistance between the 2 pins. If it's dead short, you'll probably find it's damaged the controller. But if it's open, then your coil's not going to work. And you're going to need to replace the coil.
And so you can do it from the controller, but just remember, you got to unplug it And then if you do it from the controller, there's resistance in these lines. So who knows how long these lines are running, right?
Yeah.
So
Absolutely.
the best thing to do, if you get weird resistance from here, you got to go right to the coil itself.
Yeah.
Does that make sense?
And that can totally happen because the coil plug, of course, has a rubber seal in it, but those rubber seals get old and hardened, or somebody doesn't do the gland up on the back of the plug, and very, very common to get rust in the plug, and that'll either rot the connection away and you'll get no connection, or you get a high resistance on it and it won't lift the valve. You won't generate enough to lift the valve.
Yeah.
So that's super important. Yeah, so that's if the controller thinks it's working and it's not, that is the most likely cause of you not getting any cooling. And it's the same for the other relays to the right of that. So, if you've got no fans, for example, all these relays are just voltage in one side and then the switch feed out of the other side. So that's going to be your first point. If you've got no fans, the controller's got the fan symbol on, as you can see there, is there actually any voltage coming out through the relay? And is that relay running the fans directly? Is it going to a contactor in the tray or something like that? But check there, make sure. It's something I mentioned on I think it was a LinkedIn post the other day. People like, for cost-saving reasons, running things like fans directly out of the controller. And that's absolutely fine, other than if you get a dead short on a fan and it comes to switch that fan relay, you're putting all that stress on the fan relay in the controller rather than on a contactor. Now, that contactor might cost you, I don't know, £20 in the UK, $30. The controller is probably going to cost you several hundred. So yeah. I really wish people would switch those with a sub relay, but they don't. So the defrost, if you've got electric defrost, you will almost certainly find through a contactor. Again, if your case is iced up, put it on defrost. If you push the bottom button on the controller and hold it down for 4 seconds, it'll go into defrost. And you should then see the defrost relay close. And you can do some tests from there. Have you got an output on the defrost relay? Is it pulling in the contactor? Are the heaters working? Etc. If you just touch the defrost button for like a second, it will show you the defrost sensor temperature. So in the Danfoss 550, you can assign which probe is a defrost probe. It might be the air off probe if you're an off-cycle cabinet. It might be defrost sensor in the coil if you're electric, but it will show you what that sensor value is. So if, for example, you push that button and it shows you, I don't know, 130 degrees, the chances are you got manual defrost, the relay is not going to close because it's going to go, I'm too warm, I've already terminated. But the likelihood is that's a probe failure. And actually, up on the top plugs, you can unplug the defrost sensor. If there's S5 in there, it's probably S5. If it's air off, it'll be S4. And you can do a resistance check on your probe. The Danfoss likes PT1000 probes. So resistance range is pretty tight on those. I think we have got a slide somewhere with the resistances for the probes on, Trevor, haven't we?
Yeah, I'll show them.
But yeah, you can look that up in the field as well. I think there you go on the right hand side, PT1000 probes. It's 1,000 ohms at 0 Celsius is your reference point for it. But it's like, you're talking a really tight resistance range. If you look at the difference to the NTC probe, the resistance change that you get for a temperature is quite small. So let's say you've got a little bit of water in the end of the probe, it is going to have a much bigger effect on the temperature it's reading because that's small. And it's the same with long cables. If you've got a really big cold store and somebody's used really skinny cables to wire your probes in, you're going to have a built-in error in that sensor. And we've actually done it in the past. Let's say you've got some really funny readings on your sensors. If you take the probe off at the cooler, twist the wires together and take them out of the controller, do a resistance test on it, see how much resistance is just in that cable. And that'll give you a guide as to how much you need to offset your probe by to get the right reading out of it. There's an argument to say that a PT1000 isn't the best for huge cold stores, but you are kind of stuck on certain controllers with using it. So it's worth bearing in mind for the cabling. Obviously, if you've got a quick check for you, if you haven't got the table to hand, if your case is off, let's say, and it's all at 10 degrees C, all your probes are going to have roughly the same resistance on them. If you've got 3, let's say, 1,040 ohms, something like that, and you've got one at 1,500 or one at 3,000, that probe is almost certainly going to be faulty because everything's at roughly the same temperature. They should all be saying the same thing. Yeah, so you don't necessarily, it's like a lot of things with refrigeration, it's the exact values when you're doing something like this. If you're tweaking are really important. When you've got a blatant fault, it doesn't really matter. If they're all saying 1,041 ohms and it's 10 degrees, not a major drama. If you've got it saying 3,000 ohms, you don't need to be looking into that great detail to say there's something wrong with that probe. There'll be something wrong with that probe.
Yeah.
So, worth saying as well, if very, very rarely the input on the controller will go faulty. Now, Danfoss says 180 degrees if the probe's open, but there's nothing to stop you flipping the plugs for the air on and the air off round. Let's say if you think the air off probe's faulty, but you've changed the probe and the reading still looks terrible, plug it in the air on. If it then starts giving you the correct reading and you've got no offset in there, the chances are that controller does have a fault on it.
Yeah, that point.
I will say the 550 is bulletproof, so you'd have to go some to break it. But one thing we did speak about last night, you could actually see it on the wiring diagram for the 550. Your digital inputs 1 and 2 are volt free up on the top left of the controller, but digital input 3 on the bottom right of that drawing is a high voltage input. So that is expecting line voltage to change that status. And if you have been unfortunate enough to put the line voltage one on the volt free one, it's probably not going to be very happy. And yeah, just bear in mind, and for testing as well, so DI3, and that will be your line voltage. It doesn't matter which way around the wires are. All it's looking for is the voltage difference across it. But bear in mind, yeah, that is not going to be a happy controller if you plug that into DI1 or DI2. I think that's why they put it on the opposite side, to make it really difficult to get the wire around. but yeah, just bear in mind, DI1 and DI2 are volt free, and you can configure those inputs to do a whole range of things, for stuff that's quite minor to telling the case to run or not. So one of your key statuses is status 10. So when you push that top button and it tells you the status code, it can say S10, and that is something's told me to stop. And that'll either be your digital input is configured as a run signal, or parameter. There's a software version of it as well, parameter R12, and that is what Danfoss call main switch. If you set that to 0, the controller will stop. All the outputs will go off. So yeah, if you've got status 10, something has told the controller to stop.
That would be right there. Great. Makes sense. So if I wanted to test the transducer, which is right up top here, what's the sequence of it here? Because I know this controller, this is the older version. They got a newer version, and I think it's 41, 42, 43 for their transducer, but this is 30, 31, 32. You want to walk through that?
Yeah, of course. So in this application right here, this is one controller with one transducer. So they're all ratiometric 5-volt transducers. So they need a supply, a ground, and they give you a voltage back. So 30 and 31 there is your supply and your ground, which you've got the probes on. So you should see 5 volts between those two DC. If you go between ground and S with your probes, you will see the proportional signal back. So that's your pressure reading effectively. And depending on what you set your transducer range to in the controller and what gas you select in the controller, it will give you your pressure and it will give you your calculated temperature from that. So if you've got, let's say, for example, it's not running and you've got 5 volts on where you've got the probes there, that would be maxed out on the transducer. So you've either got a system that's stopped and your pressure is very high, or you've got a fault somewhere or a missed wire. Now, Danfoss is very good with transducers. So if you imagine you can use one transducer to run a whole island of cabinets. That's great. Saves you a lot of transducers. You don't need 6 transducers if you've got 6 cabinets on an island. The pressure is going to be close enough, especially on CO2 on all those cases. And Danfoss lets you daisy chain all of that together. So all your 5 volts get linked up, or your grounds get linked up, or your signals get linked up, and you will get the same reading on each controller. The beauty of that is if you turn any case off, the transducer still gets power, you still get your reading. When we come to Carel in a little bit, you can't do that. You can only power the transducer from one controller. So if, let's say, somebody's doing a case clean, if you turn the controller off that's powering the transducer, everything's going to lose its evaporating temperature. But Danfoss is really good with that. You can feed, I think it's up to 10 cases off one transducer. But yeah, check you've got your 5 volts coming out, check you've got a signal coming back. Things can drag it down. Water in the plug will drag the 5 volts down. It's only got a very limited amount of current it can put out. It'll protect itself. The chances are you take the fault away, it'll recover. You can also take the wires out of the plug or take the plug off the transducer. If your 5 volts comes back, the fault is at the transducer end, not at the controller end. It's quite rare to kill the output from the controller. It's much more common that something drags it down in the field. Yeah.
And that's a good thing. I didn't have the slide here, but that's exactly right. Pull it off. Am I getting the 5 volts out? If you are, then, it's a transducer. And I've seen this countless times on CO2 systems where people are changing parameters, changing stuff in reality, or replacing components. In reality, it's just a pressure transducer that is faulty.
Yeah, it's more often than not something it's using to calculate the superheat or the case temperature that's gone faulty rather than the controller. The controllers are pretty solid on things like that. So we've just highlighted here the network. There's various different networks that Danfoss supports. In UK, it's really common to use the Ethernet connection. Most other places, they like to use the RS485 with the Danfoss front ends. So you should have around about 2 volts difference between your A and your B line. The 485 standard is anything above 1.5 volts difference, so that it can see what's going on. It's worth checking. I would say with network fault finding, and we could do hours and bore people to death probably on network fault finding.
Yeah.
Network fault finding is all about using logic. If you've got a whole island off, and the island next to it's on, the chances are your fault's on the cable between. If you've got one case on an island off, you can sort of break down where that fault is going to be. It's worth having a look, see if you've got a voltage difference there as a little indicator. But network fault finding, and I've done a lot of network fault finding over the years, is very much an exercise in organization and logic. Look where you've got things that are talking, look where you haven't got things that are talking, and then upset the store manager by telling them you need to get in the ceiling in between them, usually.
Yeah.
But it is worth checking.
So here's some of the status codes.
Yeah. So as I say, there's very helpful status codes on the Danfoss that's going to tell you what that controller is doing. Key ones, status 0, as it says normal, status 23, 22 that are on the screen there, all normal. It's either starting up or it's gone into regulation. They're the ones you're going to see most of the time. You might see defrost every so often. You'll know if you're expecting to see defrost, it'll say D on the screen. But that is a really quick way of seeing why is it stopped? What else am I looking at here? If it's high temp, my first place I'm going to look is, what does the controller think? Before I start doing my fault finding, let's see what the controller thinks is happening. And if it says, as I said earlier, status 10, then it's even telling you right there where you're going to look. You're going to look at the R12 parameter. Is that turned on? There was a bug. Was it I think it was actually with the E2 years ago, which should have been worked out by now, where if you got the 550s logged onto an E2 panel, there was a little bit of comms drama that meant occasionally it would switch R12 off remotely, which was not a good look. I do believe they have resolved it. I don't think the latest 550s even talk to an E2. But that can happen. R12 can get switched off. More often than not, it's a digital input, and that digital input could be a switch on the front of the tray for case clean. Simple as that. Don't discount the obvious for it. So yeah, and it will tell you. There's one for sensor error there at status 20. If you've got status 20, then you've got a sensor error.
Yeah. Okay, let's keep going on. Let's talk about some adaptive superheat. Why this is important.
Yeah, sure. So Danfoss doesn't use a fixed superheat reference. It uses adaptive control. So you tell it what your maximum allowable is. You tell it what your minimum allowable is. NO9 and N10 there. So what it does, it uses something called MSS, which is minimum stable superheat. It will try and give you the lowest superheat it can and still have the coil stable. If you Google it on Danfoss MSS, it will explain all about it. It does tell you here, like I said, I don't think, unfortunately, we've got time to go through it all today, but you will see its target superheat move up and down depending on what it can do to stabilize the coil. So you need to give it a range to work in, but don't make the limits crazy because it won't work properly. We tended to set the maximum to 8. And let the minimum start. I don't think you can set the minimum much lower than 3 and still have it work. You need, especially with DX stuff, you need a little bit of room because your sensors take time to react. If you set that really, really, really low, by the time your sensors worked out that your pipe's got too cold, you're already flooding back. Yeah. But Danfoss is quite good. It will adjust the superheat to get the most out of your coil.
And this is in Kelvin so anyone doing superheat, you would multiply that by 1.8. So 3 multiplied by 1.8 would be like 5 degrees superheat.
If we just touch on that. Yeah, sorry. Yeah, just on that one there, Trevor. Yeah, just if you're programming a lot of Danfoss cases for a startup or something like that, that saves you hours. So that programming tool, which is not super expensive, fits in the slot on the controller where your communications card fits. You pull out the communications card, which is just under that sticker there, carefully, preferably using the little hole in the corner so that you don't bust that chip that's right near the top of it. And then the programming tool slides into the controller. And you can either use that to extract all the settings out of a controller you know to be good, or you can use it to drop settings into a controller that you want to set up. And it takes like 30 seconds to go through its cycle, and you've got a fully programmed controller. Even if you don't know what settings should be in that case, if you haven't got that information to hand, you can suck all that information out of the case next door. And if that case next door is working, you're pretty sure that one's going to work on those settings and it will get you going. It's an absolute massive labor saver if you're setting up loads of cases. All you need to then set is a parameter called 003, which is the LON address, which is how the front end panel identifies it. And you can then see your parameters on the front end, and that will make your life a lot easier. EKA 183, that is, you can Google that and find one to buy on the internet. So what we used to do, this is something I've talked about on our other podcasts, when we were doing a lot of stuff with things like the 550 for a specific customer, I produced a table of all the parameters for the different cabinets that customer had that were different to default. Because if you've got to take the Danfoss manual, which has got 1 million parameters in it, to every cabinet, and you're stood there typing in the numbers and this, that, it's going to take you forever. And what we found was you could reduce it down to that, for this customer, to that number of parameters that were different to default. Because, the defaults work for a lot of things. So this gave the minimum number of parameters that people needed to change for any given cabinet. And it just makes your life a lot easier. I mean, there's nothing to stop you doing this with one of your own cabinets that you know to be good. Manually record the parameters out of it versus the list. You only need to do it once, and then it saves you every time, because you know what will happen. You'll get to the case, you'll have no 4G, which means you can't get the manual online, or you've had to screenshot it or download it or whatever else. Yeah. Sometimes it's just easier to have it. We had all our guys had this on a laminated A4. We did it specifically so it would all fit on one sheet. And if you're doing a lot of cases, it makes your life a lot easier.
But even if you look at Kevin's parameters, you got 1, 2, 3, 4, 5, 6 cases here. Look, they're almost all the same in the low temp. But you get down here, there's just a couple of parameters that are just a little bit different. Most of them are still all the same afterwards. And there's one that's a little change right here. But you got to save time doing that. And this is your base, right? Because maybe you have it in a deli or in a bakery versus back in where the meat is or back where produce is. They might have to be adjusted. And you actually have it there. You have produce and you have deli, so which is good.
Yeah. And the key things are things like the defrost sensor. So your freezers, which you can see on there from the control temps, they were electric defrost. So you want to set the defrost sensor to be S5. It's when you've got off-cycle stuff, you want to set the defrost sensor to be the air off probe. So, that's one of the key ones to set. A lot of them, you will get away without having them exactly how they need to be, things like drain down time and what have you. But things like that are going to be key. And fans in defrost, things like that in DO9, the one above it. If you've got electric defrost, a lot of the time you're not going to want the fans on during electric defrost. Some of them you will, but especially if it's a cold store, you don't want the fans on.
You don't, because that's when you walk into like a freezer or something, and it's like, oh, look at all these droplets on the roof. What's going on here?
Yeah. Oh, Santa's grotto. Yeah, exactly.
Okay, let's keep going here. We're crushing it. So there's lots more in Danfoss. You got to get into the manuals. You got to read them. You got to use your meter. You got to go out, just like Kevin said, and get your meter on a case that is working. Remember, you got to learn how to troubleshoot on systems that are working to be able to troubleshoot a system that is not working. If you don't know how it's supposed to work, how are you supposed to know how to troubleshoot it?
Yeah, absolutely. So, this is an example of the Carel. Biggest difference, really, in terms of technology, is Carel really want you to use their stepper valve, what they call on the small stuff, the E2V. If you get a big one, it's the E3V, etc., etc. So all your good stuff about stepper valves that you've probably talked about before applies with that. It's not like an AKV pulse valve or solenoid valve. If you disconnect an AKV or a solenoid valve, it'll shut. If you disconnect a stepper valve that's mid-cycle, it'll stay exactly where it is because it's on a worm drive. If you disturb that valve plug and it's driving, you're going to need to reboot the controller to put the valve back to where it needs to be, or wind the valve shut with a magnet. It's also sensitive to how those are wired up. So on a stepper valve, you've got two coils in the valve stator, 1 and 3 and 2 and 4 on the terminals there. And you can check if that's working with resistance. If you unplug the valve from the board, you'll have continuity and a given resistance on 1 and 3, and you'll have continuity with a given resistance on 2 and 4. It doesn't actually really matter exactly what that resistance is. It'll change a little bit depending on what the temperature of the coil is and everything else. But if you've got one that's, I think usually with Carel, it sits about 19 ohms. If you've got one that's 19 ohms and one that's 1,019 ohms, either your wire's broke or your coil is dead, I'm afraid to say. So, and it won't work. What'll happen is it'll either drive open and never shut, or it'll drive shut and never open. The controller will usually be able to tell you on the fault codes that will come up on Carel, it's EFS comes up on the display if it thinks the coil is faulty. It will not tell you if the valve is stuck. All it knows is what it can see electrically. It don't know if it's mechanically stuck. We talked about this last time, didn't we, Trevor, on the podcast? You will need to physically check. If the controller says it's at 0 and it's not saying EFS, it's happy the stator's working and it thinks it's shut. Whether or not it is shut is a different matter. The MXPro, the big black lump on the top there is a little battery pack. So if you power the controller off, it's got a little supercapacitor or whatever in it. It will shut the valve for you with the charge that's remaining in the controller, as long as the valve's plugged in. Interestingly enough, if you ever need to do it, interestingly for me at least, the baseboard of the MPX, they do an AKV version of the MXPro. You can actually use the baseboard of that controller for both. The module on top there with the battery in it unclips very carefully through a series of pins, and you can, if you're in a spot, take the AKV board off one and slot it onto that instead of the stepper board, and it'll work absolutely fine. You've got to be careful. There's a load of pins come up through the bottom board. You can just see the black connector to the right of the battery there. Don't bend any of the pins, but you can do it. All the parameters are the same. Parameters don't change. It's you just use different parameters to drive it. That's super key on that. Trevor's just highlighted on their transducer. So again, it's the same type of transducer, 5-volt ratiometric that you would use on the Danfoss. That's your terminals for checking the supply out to the transducer. It comes back on S6 on Carel for checking the voltage return. As I said earlier, with Carel, if you're daisy chaining it to an island, you have to use the right transducer. They've got a whole range of transducers for sharing, which are the S range of transducers. But you only link together the grounds and the signals. You power it off one controller, which does give you an issue, obviously, if that case gets turned off for cleaning. So be aware of that. There is a parameter, which we'll talk about in a sec, that will help you out during that. But be aware, if that case gets turned off, they're going to all lose their readings. That's super important. If you look at the probe order there, probe order on this is completely different to Danfoss. Yeah, so this does air off, defrost, air on, and then your suction probe, then your product probe if you've got one, then your transducer. And you've not got a ground after every probe. They share their grounds, but you see they're grouped. So the ground for the first 4 probes is just 1 pin, and the ground for the second group is just 1 pin. That's because on Carel, they let you use different transducer ranges on different groups of probes. So you can actually have an NTC probe on your air on and your air off, and use PT1000 on your superheating probe if you so wish to, which some manufacturers actually do. So just be aware of that. This is what we were saying before about the stepper valves. As I say, the controller will not know if the valve's blocked. The Carel drivers do have a setting which attempts to find out if the valve's blocked. It's called something like expansion valve to limit switch, and it'll be a fault that comes up. If the valve's sat wide open all the time and it's not cooling down, the controller will think the valve's blocked. But that won't help you if it's stuck 20% open or 30% open, and it won't know. All it knows is whether it's electrically okay or not. Worth saying on these, the older stators, which is photographed there, the plug that plugs in with your expansion valve has to be the right way around. If you can fit the plug with a little bit of effort 180 degrees out from where it should be. And if you do that, the valve will drive backwards very handily. So the tail of the cable wants to point towards, you can't unfortunately see it on that photo, but the side has got E2V written on it. This tail of the cable wants to point to the side that says V on it, and that will drive the valve in the right direction. If you've got the cable flipped 180 and it's pointing towards a bit that says E, your valve's going to go backwards, which is not going to be a good look.
Yeah.
Okay, so MOP, really important to mention. All of these controllers, and this has become much more relevant again on CO2, as people will know, on TEVs, TXVs, you could get a TXV that had a limited amount of charge in the sensing bulb, so that when you came off of something like a gas defrost, it didn't bang the valve to a massive, huge opening and flood back before it could react, or to control the pressure coming back to your plant. So what they've done on all these electronic controllers is replicate that. They're all sensing the suction pressure. So they've got a function that says, if the suction pressure is above this point, don't open the valve anymore. Now, you can use that to your advantage, especially on CO2 when you're trying to regulate load or stop the plant venting if there's a problem, and you can't get the suction under control. But it can fight you as well. So you see the settings for MOP there. You can set that very carefully. Let's say if you want to control load on HT, you can set that to limit the opening at like -1, -2 C evaporating. But if you're operating something like floating suction, that can become an issue, because you can inadvertently float suction up to a point where you've hit the MOP setting in the valve. Same with Danfoss, and the valves will all start locking up, and you'll be like, why have all my cases stopped working? The evaporating temperature is still cold enough for them to work. So it can be your friend. It can help control your load, but just bear in mind, be very careful if you're using floating suction.
Yeah, and definitely understand. Go in. That's why we put it here. Go in and read it and understand what's happening, because it's going to close. It's going to limit what's going to go through that valve through the suction pressure.
Yeah, absolutely. And if it so happens you hit MOP when your valve is shut, that's the point you'll stay at. It just won't open at all, and you'll end up eventually with all the valves shut. Okay, so
we just wanted to dive into, got to get into the fault codes. Not most of the time when you come in to a call, you're probably, not all the time, but you're going to have a lot of time. There's going to be error codes, troubleshooting. Get to the troubleshooting section of the manual. This is the Carel one, which I had a hard time to find this one on their website. I actually had to get it from one of their customers' websites, and then the Danfoss one. Yeah. But get into these. Yeah. If you read the codes, figure out, oh, this is a high alarm, high temperature alarm. Well, what does that mean? Well, something caused the temperature to increase. Now us as a technician need to figure that out.
If you read no other part of the manual, get the fault codes because that's going to give you a place to start. And as I say, like EFS is in there to say it's stepper motor's got something wrong with it, for example, a very common one to see. And S6 error on the Danfoss for transducer and things like that, really common stuff to see. Yeah, just very, very quickly, because I know we're out of time. As I said earlier, with the Carel, if you turn off the master case for the transducer, you lose transducer reading. Carel have a setting for safety evaporation temperature. It'll default to a reading if you lose the transducer, but just be really careful. If that defaults to like -10 on a lot of setups. If you're on a freezer, that ain't going to help you. Your freezer's going to break down. So make sure that number's set right, but don't set it so low that you're going to flood back, because it won't move at all till you switch the transducer back on, and you can very easily have it too low or too high.
And Kevin's an expert on this. And we were talking about yesterday, we had the manual. We couldn't find it very easily. So we know this is hard for you guys out there. He's been working on these for 10, 15 years. And we know that, but what you need to do is take the time to go through there, get a contact at one of these manufacturers. Don't abuse the relationship, but use them after you understand how to use this stuff, okay? And get out and ask them the questions and call them up when you do have a real problem, because they want to provide you with that solution, because sometimes they don't have that answer. And don't blame them either. They got to go in and get the control, and they got to look at it, and they got to call their experts, their senior experts, okay? So just utilize them when you can.
Absolutely. And yeah, you see it doing things that they'll rarely see it do. So they'll get the answer eventually, but it's not a substitute for the things we all see in the field. They see it under test conditions, and they'll see a certain number of things. And unless they've been about, they won't necessarily have seen the same things that you see. They do their debugging in the field the same as we do ultimately.
Yeah. But this is how you got new product. They do their best, and they test in their lab, all the manufacturers, Copeland, Microthermal, RDM, Carel. I go on the list. They're all doing their best to make the best product in this competitive market. But there's some things there's issues that do happen. Most of the times, the highest percentage of the time, it is us as technicians or the customer that are making the mistakes most of the time. So just
the answers are there. We've just got to find them. Yeah, absolutely.
Somebody just threw in the chat, Danfoss Cool Code app is a big time saver. So it has error codes, programming guides, troubleshooting tips.
Absolutely.
So definitely check that out.
That's
Kevin. Man, this was a flash course. And we could talk about this for 2 days straight. I've been into many of these different trainings, and this was by far the best that I've learned so quickly. Kevin, always. I love it. Any final thoughts on case controllers for technicians who are out there either starting up or going to service on these case controllers, or any?
They're all doing the same thing. All you need to learn is their little foibles of how to do it, what order the probes are in, what it likes to see, and fault codes. Start with the fault codes, and your basics are always the same. Is it driving the valve? Can it see all its sensors? They've all got their own codes for it, their own ways of doing it, but they're all doing the same thing. They're switching a valve on, switching fans on, making something cold. It's just a matter of learning its specifics that it likes.
Love it, Kevin. Thank you so much for taking the time to come on, CO2 experts. I know we're going to have you on again, because you're just such a wealth of knowledge, and you care about the industry. You care about the people in the field. And that's what I love about chatting with you and learning with you. Thank you so much for taking the time, and we'll see you at the next CO2 experts.
Pleasure. Thanks, Trevor.
Fantastic. Awesome, man. I learned so much. Again, like yesterday, we spent a half an hour or an hour. Time goes by quick when we're learning.
Right.
And man, I learned so much.
It's one of those things you could do hours on them. It's finding enough that people can get something out of it quickly, isn't it? Because there's so much you could do. You could do an hour or more on each one of those easily. But
I just spent 2 hours before this training on CO2 with a group of technicians, very smart. But the same thing, it's like I got through like 4 or 5 slides because there's so many good questions and understanding. Okay, what's actually before that high pressure valve? Is it a fluid? How much liquid or vapor is in that fluid before it goes through the high pressure valve? And what does that mean? You know, how it acts up.
Yeah, it's something. When we used to do the CO2 training in our test center, we used to say, you know, it does change, but actually it's also really important to know what difference does that make in the field to you. You know, it's because people get so worried about that valve, don't they, and what that valve's doing. And you're like, look, it's 99% of the time that valve is not going to be your problem. It's doing its job. All it is a restriction in the pipe. You know, so as long as you know what it should be doing, you know, don't worry too much. People get like super like wound up about that valve, and you're like, it's, you know, like it's some magical thing, and you take the head off it, it's just a restriction in the pipe, isn't it, ultimately? So yeah,
it's just a regular pressure regulator, right? It's just just opening, closing on a control based on what we tell it to do. And when you can really understand that, and at the end of the day, it's just another refrigeration system. Because I'm training on chillers now. I'm training on supermarkets. I'm training on A2Ls and propane and CO2. And it comes down to it. It's all doing the same thing. We got to increase pressure and decrease pressure to move heat around the system. Do we need the heat? Do we need cooling? And this is why I love training and just teaching all these different contractors around the world and technicians.
Yeah, it's TXP 2.0. Do you know what? That's a very valid point, Tom. Everything comes back to the TXV. You know this. That's the refrigeration engineer's mantra, isn't it? It's always the TXV.
Yeah. Let's add some more gas. Fill her up.
Yeah, that's right. Yeah, more gas. Put a new valve on it. It's one of those.
Let's add some oil. I was having a conversation yesterday or the day before. It's like, was it yesterday? Yeah, my friend Paul from Hill Phoenix, and he does all field startups. It's similar to some of the stuff that you do out there. And he was telling me, like, I'm getting calls, compressor bitzers are failing, and it's like, oh, it's a Hill Phoenix, or oh, it's the problem with the bitzer. And then when they get back, there's 7 gallons in a 4-gallon oil system. I'm like, why is there 7 gallons in the system, right? Well, compressor broke. They add some oil into the system and then don't take it out. Well, why are you adding in the first place? Like, there's a process to get it back without, use compressor 2 and compressor 3 to get it all back. You know what I mean? But this is stuff that people need to learn.
On Hill Phoenix, I mean, Advancer in the in our part of the world, we used to see so much of people going, and the pack would be stopped usually because it run out of oil because the temperate filter had failed, and they just go, they look in the receiver, all the CO2's migrated out because the system stopped, and they're going, there's no gas in it. So they throw a load of gas in it, they switch it off and on again because it still wasn't working. It would then start, but if 2 or 3 attempts at that, all that happened is the receiver would be full, which what bit of oil they had in it would then get washed out, and they'd be like, we can't get the pack to work. We must have a massive leak. We've put 20 bottles in. And you'd go there and you'd look in the top sight glass. The top sight glass is full in the vessel, and you'd be like, tell you what, we'll have to lose like 100 kilos, and then we'll change the temperate filter. But it's the old thing, isn't it? More gas, more oil.
Yeah. But the thing is like when I do my trainings, when I'm doing CO2 training, and it doesn't matter, any refrigeration systems, if I'm doing a program, I ask them, if you're adding gas, why? Where's the leak? Like, did you see the leak? Did the pressure relief go on the top? If you're adding oil, why? And then if you're adding, where did it go? Right?
Yep. No,
and you can verify. This is all facts. There's nothing but facts in refrigeration. When you start assuming, that's when the problem. Give me the numbers. I'll tell you what's going on.
Yeah. No, absolutely. And, the thing with the CO2 is people, it's a little bit less now. People have got a bit of a better attitude to it. People started off a little bit like, so there's a leak, so what? Into CO2, it doesn't matter. I'm not going to go spend 6 hours looking for leak testing, because leak testing is really boring. I'll just put 3 bottles in it and we'll be on our way. But it actually gives CO2 a really bad rep, because people go, oh, CO2 leaks all the time. So, no, it doesn't. What happens is people think it's only CO2. I'm not legally obliged to go look for the leak. So they don't, or they go, oh, it was on the Schrader, standard. That's one step away from the TXV 2.0, isn't it? It's on the Schrader.
Well, there's ball valves in front of all those now. There's no Schraders. Yeah. So come on now.
Right.
So, you know what I mean? So, but that's it. And it's just getting them to realize every time I'm doing a CO2 program, I'm telling them, do not be just shooting that gas to the atmosphere. It's still GWP of 1. But you move it, get your recovery unit. Well, it's a high pressure. You can't move. Yes, use your recovery unit. It's not, you're not moving it at 1400 PSI. You're moving it at, 500 flash tank. Or instead of the suction line is 400, 500 PSI. You can move that with the recovery.
You can, yeah, absolutely. And you can be really, you can do pretty much all the things you did to move gas around to avoid taking it out of the system. People think you can't, let's say, pump the suction line right down on the rack, if you're going to change the suction filter. You can. It's not, if it's vapor, it's not going to dry ice. You can push the contactor in and pull that down to 0. You don't have to. No, it doesn't close the valve instantly. It just stops it opening anymore. So it will stick at the percentage it's at.
Yeah, the question the person asked was, does the MOP close the valve? Yeah. So it'll stop at that. And then I know on the Copeland or Alco ones, it was, or the the Dixel controller, it would stop at that point, and then it'll close 10% per second, depending on how you set it up, until it stays at that pressure. So depending on the controller.
Yeah, it does. I mean, it's initially they all work like an MOP expansion valve would have worked back in the day. It will just sit where it is.
And so the floating point, so what was Kevin was talking about, if you put that MOP close to the floating point, then all of a sudden the valve needs to open more, but it won't, because you hit your MOP. Because with I'm assuming floating suction, you want to increase the pressure of your suction as high as you can. The higher, the better, because as long as you maintain temperature, that's a huge energy gain.
Yeah, and let's say you've got a supermarket with all doors on the cabinets at night, especially when nobody's opening those doors. You don't need the full duty of that cabinet to keep it cold. You could be evaporating the thing at -4 during the day, let's say, because you've got air changes and all that, and you want to get the product down. At night, when all the doors are closed, you could probably evaporate that at -2, -1, and it'll still do enough. But if you've got your MOP set too tight, it's going to start clashing. Your valve won't open at all, and you'll be like, "I've done something. What have I done wrong? Why is it now not holding temperature anymore?" So yeah, it's when you're using floating suction, really, you've got to watch that. And floating suction has become really popular for energy reasons.
And I think one of the big things is that I talk to all the control manufacturers, and all their controllers can do it. The problem is it's not being done in the field, and we run into this issue, and then it's like, floating suction is no good, or it doesn't work, but you don't understand it because Danfoss, CC200 or Dixel or RDM, all of them, Worm in Germany, all of them, they all do it, but we need to set it up properly. And if that's not set up properly, it's not going to work.
So I think, and I mean, it's something I've talked about before with people. What happened, I think, was when we started bringing floating suction in, we were trying to roll it back onto systems and equipment that wasn't suitable for it. So you had racks with no VSDs, you big capacity steps, you had cases that couldn't do duty at anything less than like -10 evaporating, but you'd have them on the same circuit as something that could do duty evaporating -4. So you'd end up short cycling the plant. So your suction pressures lie all over the shop, and nothing settles, especially with electronic valves. If the readings don't settle, they are not happy, and they'll shut because the superheat's gone. With a TEV, it won't just shut. With the electronic valve, it will. And so you lose temperature, and everyone says, well, floating suction doesn't work. My friend Connor, who works for one of our consultants in the UK, he is a big believer in floating suction, and he is absolutely right that it works really well. It just has to be the right application for it. It's not suitable for every system. Your targets have got to be realistic. If you think you're going to get 0 degree shelf temperature out of 0 degree evaporating, you're not. You've got to be really sensible with what you're asking for.
Yeah, and that's important. It's understanding technology. And the thing is, these controllers have this advanced technology, but if it's not set up properly or maintained or serviced properly, because all of a sudden it could be running It's just like subcoolers on a rack. I've seen this so many times. Don't understand a subcooler. Someone changes something, just the valve, all of a sudden the subcooler's on a rack, and then the whole liquid quality going out to all those cases is done. You know what I mean? Now the whole system's running warm. It's no different than this. You need the high pressure and the bypass valve working in sync with all your TXV, all the electronic valves. When they're working right, your system's going to work right. That means your VFD is going to work right. Your digital compressor, whatever it is, it's all going to be in sync. And that's the fine tuning. And I think that's the good thing.
Yeah. And floating suction is going to expose all of those problems when you try and do it. You know, when you've been getting away evaporating the thing at -15 because nothing else is working, and all of a sudden the floating suction comes on, it is going to expose. But also things, you know, if you've got, as everyone has in the big stores, where you've got an AHU blowing into the cabinet, and you've just about been hanging on to it, you know, things like that are going to get exposed.
Yeah. And this is the thing. This is what I like about CO2, because it's making people better at refrigeration, where we cut a lot of corners. I've done it. And then we went away. Oh, well, let's drop the rack pressure of a PSI or two, or, you know what I mean? Like have a bar to make them.
It's brought back a lot of skills, actually. Yeah. It's, you know, things like MOP, which everyone's forgotten about, or even working on semi-hermetics, you know, taking apart, something you talk about a lot, taking apart semi-hermetics. Semi-hermetics in the UK, especially in supermarkets, virtually disappeared when we were using Freons in favor of scrolls, because they're efficient. They're super efficient. But when it's broke, isn't it? You know, I mean, yes, you need to find out why, but you ain't repairing it. It needs to go. So the skills for stripping apart the semi-hermetics were lost, you know, and people are now rediscovering that through CO2, because you got virtually all semi-hermetics. Yeah. So yeah, it brings back a lot of good stuff.
And there's still a few people on here. I got a compressor course coming up in a week and a half, so you should join it.
Yeah, absolutely. It's good stuff to know.
Yeah,
one of my favorite parts of the job.
I think that's what people, even people think that, okay, well, I know compressors, it's not a big deal, I can figure that out. And so my classes, when people leave my compressor class, they're like, holy, I've been doing this for 15 years and I knew a lot of it, but that little tip there, I was at there, I know that's the wrist pin. I know it's now, and they go out and fix the problem from the course. I love that.
I have seen, and I won't bring up names, but I've seen on some other podcasts and training stuff that's out there, people saying you can do this when you go into this compressor because this is here and there. It's not. I can absolutely guarantee those things are not right. You know, you want to go do it yourself. You want somebody to have that machine apart in front of you, you know, on, like you say, with your training or whatever. And when they say, oh, you can do this because of this, you'll go, no, because these are the actual parts we're talking about. And you cannot do that. Or you can, you know, you can change this piston assembly on site, or you can't, you know, and it's good to have the confidence to get in there. I am going to have to go, actually.
Yeah, me too. Awesome. Totally have a great one. Thank you so much. We'll catch you again at the next one.